This podcast will explore other possible ways to handle problems that involve the chain rule for derivatives. I'm going to start by looking at what I consider the old school method of doing the chain rule, and that is having a function that we compose with two functions, f of x and g of x. And normally we would refer to that as the derivative of the outside times the derivative of the inside. Now the new way to look at this would be to continue to look at f of g of x, but this time make u the inside function. So now we look at something, instead of f of g of x, we're just looking at it as y equals f of u. Now this would change our definition of the chain rule very slightly just to read f prime of u times u prime. And what that really means is that we're taking the derivative of the outside times the derivative of the inside. Still the same, but we're just classifying it a little bit differently to try and streamline some of our work. So we're going to have this function we call u now that we're going to be taking the derivative of, hopefully highlighting that inside function so we don't miss it. So here's an example. Let's suppose we have the cube root of the quantity x squared minus 1 to the second power. Of course, we could rewrite that as x squared minus 1 to the 2/3 power. We're going to let u equal x squared minus 1. So what we do is we take the power rule into effect here, bring the 2/3 down and reduce the power by 1. And we also take the derivative separately of the function u, and that's just 2x. We go back to our definition now, f prime of u times u prime, and I think it looks a little bit easier now because we realize that our final answer is basically going to be 2/3 times the 2x, getting us 4/3 x, times our function u to the negative 1/3 power. We also have an alternate way of saying that, right? 4x over 3 times the positive exponent cube root of x squared minus 1. Let's look at one more example. Let's take a trig function this time, tangent of 5x to the 7th power. We're going to let u equal that function inside the angle portion, 5x to the 7th. So again, we've differentiated here. F prime of u alone is just the derivative of the tangent function, which is secant squared. We keep the 5x to the 7th. The derivative of u by itself, 35x to the 6th. And the chain rule basically says, with our new school definition here, we're basically going to just take those two results and multiply them. And so therefore, we get 35x to the 6th secant squared of 5x to the 7th. So hopefully through these first two examples you can see how this may or may not help you. I think it might be a little bit easier than what you might be used to. Now let's look at one that would really be difficult, very involved. Call this a super duper double chain rule. Now you look at this and you know that we're going to need the chain rule here, but did you recognize that we're going to need to use it twice? How do we know? Well, again, we have a function to a power, but within that we have another differentiable function. Right? This pi t plus 2 piece is hiding inside the angle, and that is really the giveaway that says we're going to need to do chain rule twice. So, again, we're going to let our first u function equal cotangent pi t plus 2. S prime of u, bring the power down, reduce it by 1. The derivative of the inside piece alone is negative cosecant pi t plus 2, cotangent pi t plus 2. But now here's the thing. There's a second function hiding inside. We talked about that before, pi t plus 2. And if we let that be, let's say, u subscript 2, then the derivative of that is simply just pi. So now, what would this look like? Well, when we apply the chain rule here, we're going to be looking at the original outside function times the first inside function times the second inside function, all derivatives. And so you mush all these together and you get 2 cotangent pi t plus 2 times negative cosecant pi t plus 2 times cotangent pi t plus 2 times pi. Put it a little bit more simply, a little bit more streamlined, And you see the answer we have here. Is it big? Yes. Is it ugly? Yes. But is it correct? Absolutely. Okay, let's have you try an example this time. Let's have you try sine cubed of the quotient 4x over x minus 3. And so, if you have a chance, go ahead and pause. And when you're ready, you can come back. Okay, now hopefully you get this answer. Obviously it's very messy. If you clean things up a little bit algebraically, you should run up with our final answer that we see here. I hope this helped. Thanks for taking a look at breaking the chains.